Hello, here are a couple of problems I was asked to do. This first one, 2.4, number 5 in the online work, which is number 27 from the book. It says, find the derivative of the function y equals 3x over the square root of x squared plus 3. And I like to write this instead as y equals 3x over x squared plus 3 to the 1/2 power. So the derivative y prime would be, now we've got a quotient rule here, low d high, that's x squared plus 3 to the 1/2 times the derivative of 3x is just 3 minus high d low, so that's going to be 3x is the high. The derivative of what's down below is 1/2 times x squared plus 3 to the negative 1/2, because that's 1/2 minus 1 is negative 1/2, times the derivative of what's inside. So what's inside is x squared plus 3. Its derivative is 2x all over the square of what's below. So we have x squared plus 3 to the 1/2. I'm going to square that amount. And I'm not going to multiply this through yet, these powers. I'm going to leave it like that because I get the sneaky suspicion that we're going to be dealing with something here with that x squared plus 3 to the negative 1/2 power. So our y prime is going to be, I'm going to go back to square root symbols now. Square root of x squared plus 3, that's our x squared plus 3 to the 1/2. I put the 3 in front. Minus, now notice I have a 2 here. And then a 1/2, so those are going to divide out. And we have 3x times x is 3x squared over, and this is just going to be the square root of x squared plus 3 all over the square root of x squared plus 3 squared. Now I have a complex fraction issue right here. So I'm going to multiply the numerator and denominator by the square root of x squared plus 3 over the square root of x squared plus 3. So that y prime is going to be 3 times the square root of x squared plus 3 times the square root of x squared plus 3. That's from distributing the square root of x squared plus 3. Minus 3x squared over the square root of x squared plus 3. I just rewrote what we had there. Times the square root of x squared plus 3 over the square root of x squared plus 3 squared times the square root of x squared plus 3. So our y prime is going to be what? What will reduce out? This reduces here. That was our whole plan. And we have 3 times, now we have the square root of x squared plus 3 times the square root of x squared plus 3 is just x squared plus 3. And then minus that 3x squared, that's what's left there. Down below we have the square root of x squared plus 3 cubed. If I distribute this 3, it's 3x squared plus 9. 3 times 3 is 9. Minus 3x squared over the square root of x squared plus 3 cubed. 3x squared minus 3x squared is nothing, leaves 9 over the square root of x squared plus 3 squared, and that is the answer. Okay, the second one was 2.5, number 10. We have, it asks us to find the second derivative of y with respect to x in terms of x and y for y cubed equals x to the 5th. So we'll take the derivative with respect to x of y cubed equals the derivative with respect to x of x to the 5th. So d dx of x of y cubed is 3y squared times y prime, because y is a function of x, but we don't know what that function is, so we leave it as y prime, or you could leave it as dy dx if you like that notation better. equals the derivative with respect to x of x to the fifth is 5x to the fourth. So we have 3y squared y prime equals 5x to the fourth. I'll divide both sides by 3y squared. Y prime is equal to 5x to the fourth over 3y squared. Now, we're not finished. We need to go a step further. So let's take the second derivative. So take the derivative with respect to x of y prime. It's going to be the derivative with respect to x of 5x to the fourth over 3y squared. So it's y double prime on the left equals, now we have a quotient rule, low d high, so it's 3y squared times the derivative of 5x to the fourth is going to be 5 times 4x cubed minus high 5x to the fourth times the derivative of what's below, d low. That's going to be 3 times 2y times y prime. Remember, anytime we do a derivative with a y, because we're taking the derivative with respect to x, we have to do the y prime. All over 3y squared squared. So y double prime is going to be, see here, 3 times 5 times 4 is 60 x cubed y prime, or sorry, that's y squared, minus, now we have 5 x to the fourth times 3 times 2 is going to be 30 x to the fourth y prime over 9y to the fourth power. Give myself some more room here. Now, let's plug in what we know for y, what y prime is. Y prime is 5x to the fourth over 3y squared. So y double prime is going to be 60 x cubed y squared minus 30x to the fourth y times 5x to the fourth over 3y squared over 9y to the fourth. Rewrite that here. Y double prime equals 60 x cubed y squared minus 30 x to the fourth y times 5x to the fourth over 3y squared all over 9y to the fourth. Now I'm going to multiply everything by 3y squared. Just to clear that, well, maybe not 3y squared. Let's look at that. I can probably reduce this a little bit. So the 3 can divide out with the 30, leaves a 10. The y squared divides out with the y, leaves a y down below. So if I multiply everything by y over y, we'll have 60x cubed y cubed minus 5 times 10 is 50. X to the fourth times x to the fourth is x to the eighth times y, no, the y's cancel, over 9y to the fifth power. Now here's the part that gets kind of interesting. We have the relationship initially given to us that y cubed equals x to the fifth. And so I'm going to start using the substitution that is part of this problem. I'm going to put x to the fifth in place of y cubed up here. So this becomes y double prime equals 60x cubed times x to the fifth. This replaces y cubed minus 50x to the eighth over 9y to the fifth power. That becomes 60x to the eighth minus 50x to the eighth over 9 y to the 5th. And we end up with 10x to the 8th over 9 y to the 5th. And there's an answer right there, and I like that answer, but we could probably work this a little bit more like we just did, some substitution to bring these powers down. Excuse me. So 10x to the, now what I say, it was x to the 5th is equal to y cubed. So what if we treated this as x to the 5th times x to the 3rd over 9, and y cubed is x to the 5th, so break this y to the 5th down to y cubed times y squared. Then we have 10 times the x to the 5th becomes a y cubed. This x to the 5th becomes the y cubed times x cubed over 9. This y cubed becomes an x to the 5th. This y cubed becomes the x to the 5th, and we're still basing it off of this relationship. And we still have a y squared there. So if it's 10 times y cubed times x cubed over 9 times x to the 5th times y squared, this is what happens. It's kind of fun. The x cubed divides with the x to the 5th, leaves an x squared. Y squared divides with the y cubed, leaves a y up on top. We end up with 10y over 9x squared, and this is what the computer has for an answer. So I know that's kind of a complicated way to get there. I hope it makes sense. I hope that you can follow that. So let me know and have a good day. Oh, before I end this, I wanted to say that this is number 49 from the book. And it'll be slightly different probably than what the book has. They changed coefficients. It might be y to a different power, x to a different power. So, okay, have a good day.